Okay, I made a little mistake on the first one. I'm starting this one over. So finding zeros is a big deal in calculus, in pre-calculus, and in math basically from this point forward. You have these little shapes that are wiggling through and zeros, 1, 2, 3, 4, 5, like those, this would have 5 zeros maybe down there, and those are all points of interest. And then your shape might also take a bend up here and right there where it's bending but not touching the x-axis. Those would be the imaginary ones. And those are also points of interest because see right here it's like an upside down parabola, and right here it's an upside up parabola. Those imaginary zeros are where it changes from one to the other. It's where it's going upside down to upside up. Those are interesting points in calculus also. So finding these zeros is a big deal. So like right here, the top degree is how many zeros there might be. So this one would have 3. It'd be 1, 2, 3, so it could look like that. Or it could be shifted so they could all 3 be real, or maybe only one of them is real and the other 2 are imaginary. So it's either got 3 zeros or 1 real 0, but it has 3 total. It could be 1 real and 2 imaginaries, or 3 reals. Now remember, the imaginaries come in pairs, so they have to, it's either 3 or 1. Okay, so the task is to find that, and we have a couple ways to find that now. Getting it to the quadratic formula, of course, is the key, because by now everyone has gone to the Student Center and bought a TI-83. We have put in the program, the quad program, so that we can do this faster. So it's time you have one of these. It's going to be necessary for everybody to have one. So if you have not gone down to the Student Center, it is time to do that. Okay, so when I take a look at this one, I see an x to the third, x to the second, and an x. Well, factoring is another one of the tools in our toolbox. I'm going to factor out an x. That leaves x squared minus 3x plus 2. Now, any factor is equal to 0, so that means this one right here is equal to 0. And then we can find this one. Now, I can either factor it or put it in my quadratic formula. If I factor, this is an easy one to see. Negative 2 times negative 1 is 2. Those add up to negative 2. Those add up to negative 1, so it adds up to negative 3. So those would be the factors. And like I just said, every factor is a 0. So 2x minus 2 equals 0. This one is at 2. And x minus 1 equals 0. This one is at 1. Okay, so I have 2 positive roots and then 0. So it looks, we know exactly what it looks like. It's crossing right there, it's crossing at 1, and it's crossing at 2. It's looking something like this. Now, just as a review, we knew it was going to have two positive zeros because look at the sign changes. That was positive to negative for 1 sign change, negative to positive for 2 sign changes. That meant there was 2 positive zeros, and right there they are. Okay, so we could have done that on the quadratic formula too. I just said everybody has the quadratic formula. It was so easy to factor, that seemed faster. But if you don't like factoring at all now, you can always go to the quadratic formula. A is 1, B is negative 3, and C is 2. And see, there's the same answers, 2 and 1. Actually, the quadratic formula now is giving us the zeros, if we can get it down to that. So number 2 is exactly the same. There's an x in all of that. So if I remove an x, it goes right to the quadratic formula. This one is done, so one of the zeros is at 0. And of course that makes sense. If you put 0 right there, you got 0 to the third plus 8 times 0 plus 11 times 0. Well, that's 0 plus 0 plus 0. Yes, that equals 0. 0 makes it true. What else makes it true? Well, we could try to factor that, but I don't want to. So then we go to the quadratic formula. The quadratic formula is negative b plus or minus b squared minus 4ac all divided by 2a. So this is 64 minus 44. So that's negative 8 plus or minus 64 minus 44 would be 20 all over 2. Now I'm doing it like this just to show you what books tend to do. That 20 is really the square root of 4 times 5, so the 4 can come out as a 2. So that's really negative 8 plus or minus 2 square roots of 5 over 2. This top has a 2 in it, so I could factor the 2 out. So if I factor a 2 out, it would be negative 4 plus or minus the square root of 5 over 2. And now those 2's cancel out. So if this problem was in a book, it would say 0, and then it would have the other answers as -4 plus or minus the square root of 5. Now I say that you can go ahead and answer this as a decimal, but so what that would be is -4 plus the square root of 5. So one of them is -176 about, because if we have to plot it, we got to basically know where that is, and then -4 minus the square root of 5 at -6.24. Okay, so those would be the decimal answers, those would be the exact answers. So if they are ever asked for an exact answer, they want it like this. They want you to do the quadratic formula by hand. But if we put that in our quad program, the A term was 1, the B term is 8, and the C term is 11. See, there's the same answers, -176 and -624. So you can answer it like that. I had you write that program so that we could use it. So -176 and -624, we could have gone right to that real quick without doing it by hand. Okay, so get to the quadratic formula. That's one strategy. What if we just can't factor out an x and it's right to the quadratic formula? Okay, we have a couple versions of this. This is probably the one people are going to take, but I'm going to do two. Probably people will go 1, 1, 1, 1. The rational root theorem says last over first, so the factors of the last is 1 times 1, and so the only possibility is plus or minus 1. So if it's going to work, it's going to either be 1 or -1. There's 3 of them. I need to find one this way to get it to the quadratic formula. Okay, 1 times 1 is 1. That adds up to 2. 1 times 2 is 2. That adds up to 3. So that's not going to do it. So it's not positive. I'll try -1. -1 times 1 is -1. That adds up to 0. -1 times 0 is 0. So that adds up to 1. -1 times 1 is -1. See, that one works. So x equals -1 is one of the answers. Now, this started out as a third. We took one out, so this one now is a second. So that means 1x to the second plus 0x plus 1 equals 0. Okay, have a quadratic formula for that. 1, 0, 1. Put that in. Okay, it's plus and minus I, so they're imaginary. So the other x is plus and minus I. Okay, so they're imaginary. So later on when we graph this, it's going to cross at -1, and then it's got a couple wiggles over here at positive and negative. Well, that's actually not where they would be, but you don't have to care how to graph those yet. Okay, so I say there's a couple ways. One way to be the rational root theorem, find one, get to the quadratic formula, use your calculator. The other way for this one would be, okay, I got x to the third plus x to the second plus x plus 1. I just want to do a reminder on some things, a little bit of a review. We're getting to the end of this unit, and you'll have to be able to do this at least once, is to factor by grouping. Okay, if I group those like that, I could take an x squared out of this one, leaving an x plus 1. This is already an x plus 1. Okay, these two groups are the same, so I can call them q. So I have x squared q plus q equals 0. Now I can factor out the q. Dividing the q out of that leaves x squared. Dividing the q out of that leaves 1. But q is made up, so this q was really x plus 1, and this piece was x squared plus 1 equals 0. See, now we have it factored, so each piece equals 0. So see, there's one of them. Move the 1 to the other side. There's the real one, -1. And here we have x squared plus 1 equals 0. X squared equals -1. And now when I square root that, there's the plus and minus imaginary. The square root of -1 was imaginary. So I got the same answers by doing it by factoring. Factor by grouping. But like I say, probably most people will get it like this. I would. Okay, number 4. There's 4 zeros, so if I do it with the rational root theorem, I have to find 4 of them. I mean, I have to find 2 of them and then try the quadratic formula. Or I can notice this is a 4, a 2, and a 0. This is already in quadratic form. I might be able to get it to factor right now. Well, it looks like 9 times 4 can also add up to 5. So if I factor this, x squared and x squared makes the first. 9 times 4 makes the last. I need these to add up to positive 5. So there's 9x, I'll make that one positive. There's 4x, I'll make that one negative, and we'll have the positive 5. So positive and negative. Okay, now when you have factors equal to 0, each piece equals 0. So x squared plus 9 equals 0. Moved the 9 to the other side. And square root. Okay, the square root of negative 9. It's plus and minus. Okay, well, first the imaginary comes out, and then the square root of 9 is 3. So it becomes, there's two answers, positive 3i and negative 3i. And then this one up here, x squared minus 4 equals 0. Okay, move the 4 to the other side. Square root. Now the square root of 4 is plus and minus 2. So there were 2 real answers and 2 imaginary answers. That makes all 4 of them that I was looking for. Okay, number 5. Right off the bat, I noticed this as a perfect cube, so that makes me think, okay, this could be one of those cube ones. There's going to be 4 answers. Okay, let's take a look here. They do all have an x, so I'm going to factor an x out of that, and that makes it x to the third minus 27 equals 0. Okay, well this part right here is done. One of the answers is 0, so there's 3 left. Okay, I've got a couple choices. I could try to do this with the rational root theorem. The rational root theorem would be 1x to the third, 0x squared, 0x, and then negative 27, and try to find it. Okay, well, the only possibilities are last over first. So the factors of 27 are 1 times 27 and 3 times 9, and the factors of the first are just 1. So it's either going to be 1, 3, 9, or 27. And then also the negative. So there's 8 possibilities. Of course, I would try 1. I only have to find one of them because this is a third, and if I can find one of them, I can use the quadratic formula for the others. 1 times 1 is 1, add is 1. 1 times 1 is 1, add is 1. 1 times 1 is 1, does not make 0. Try negative 1. 1 times 1, negative 1 times 1 is negative 1, add negative 1. Negative 1 times negative 1 is 1, add 1, negative, so it's not 1. Looks like it had to grow, so I think I'll just go down the list and 1, 0, 0, negative 27, and try the 3. 1 times 3 is 3, add is 3, 3 times 3 is 9, add is 9, 3 times 9 is 27. Okay, found one. I dropped down the 1, 3 times 1 was 3, add, 3 times 3 is 9, add, 3 times 9 is 27, add, made it. So one of the answers is 3. So now I found 2, x equals 0 and x equals 3. This was the third power, so this is the second power. This is x to the second plus 3x plus 9 equals 0. Got it down to the quadratic formula. I'm going to use my program for the quadratic formula, 1, 3, and 9. Okay, those are imaginary when it does that. So it's negative 3 halves plus 2.6i. And then it was negative 3 halves minus 2.6i, so we can answer them both that way. So there's all 4 of them. Now, I want to show you the other way. I said there was 2 ways, and this would be one way, is to try to find them with the rational root theorem. But there's another way that I want to remind you about. So this one is still there. I want to take this part and review what's happening there. Okay, that's the letter x all to the third, and then minus 3 all to the third. That's the perfect cube kind of formula. This is the a number and that's the b number. Okay, you have to remember how this factors. It factors into a minus b, so x minus 3. See, that's where that 3 came from. Then the next one is this piece squared, a squared. Then it's the opposite sign, so plus, and then it's ab, so 3x, and then it's the last one squared, so plus 9. Okay, x minus 3 equals 0. There's the 3. And then the other part, see how it's exactly the same as we got over there? We'd put that in the quadratic formula, and we would get negative 3 halves plus or minus 2.6i. So either recognize that as a perfect cube and factor it, or you put it in the rational root theorem system until you find it. Okay, number 6. It's going to be 4 answers. I see right away that x is one of them. 0 is one of them. I'm going to take an x out of that, and we have x to the third plus 2x minus 2. So here's one of them. X equals 0. So there's one answer. There's 3 left. I'm going to find one of them with the rational root theorem and then get the other 2 out of the quadratic formula. Last over first. Okay, so the factors of the last are 1 and 2. The factors of the first are just 1. So my possibilities are plus and minus 1 over 1 and 2 over 1. So there's only 4 choices. Okay, let's try them out. 1, 2, negative 1, negative 2. We'll start with 1. 1 times 1 is 1, add is 3. 1 times 3 is 3, add is 2. 1 times 2 is 2, found it right off the bat. It was 1. There's 2 answers. Now, this was a third power, so we found one. That makes this a second power. So this is 1x to the second plus 3x plus 2 equals 0. Okay, that's a really easy one to factor, but it's also easy just to put it right in my calculator. 1, 3, 2. So the answers are negative 1 and negative 2. So we have several techniques now that we want to combine to get to the zeros as fast as possible.